Good morning, geometry students. I tested the mic before recording this one, so I know that it has audio. So yay, happy Tuesday. Thanks for tuning in. Flipgrid question of the day is at that link, and you have already found the YouTube lesson. Good for you. The problem, which you should pause this video and do in your notes, is to find the values of u and t using sine and cosine. We need to round our answers to the nearest tenth. That is good information for us, so make sure that you pause this video and try it yourself, then unpause it and do it with me. Okay, alrighty, so I'm noticing that this is our angle right here, 65, which means that this side is our opposite, this side is our adjacent, and of course the hypotenuse is always opposite the 90-degree angle. Perfect. So now, let's see, to find t with my opposite, here I'm going to put this nice and big at the top. Sokatoa. Write this everywhere on any of your trig stuff. Just write this because it helps you remember. So, sine of 65 degrees is opposite over hypotenuse. And now, to get that t by itself, we're going to multiply both sides by 8. So those will go away. And now we have 8 times sine of 65 degrees equals t. What is that, you might ask? Don't know. Do not know what the sine of 65 degrees is, but my calculator tells me that 8 times sine of 65 degrees is approximately 7 point, nearest tenth, 7.3. And I use the squiggly equal sign to say approximately. Fantastic. Okay, we are running out of space, but that's okay, we'll do it here. Cosine of 65 degrees. Remember that cosine is adjacent and hypotenuse. That's what the A and the H stand for. So cosine of 65 degrees is u over 8. Cool. Same thing as last time. We're going to multiply by 8 on both sides to get those to cancel out. And now, 8 times cosine of 65 degrees is 3 point nearest tenth, 3.4 approximately is equal to u. Beautiful. Fantastic. Okay. That is the entry task problem of the day. Let's move on to what we have for today. Our learning target is, I remember what sine and cosine are. Today we're still using sine and cosine. The success criteria is that you can use sine and cosine in special right triangles and to solve real-world problems. So remember your special right triangles, that'll help today. And we're also going to do some real-world application word problems today. Okay, so the first thing we need to do is remember yesterday. Remember, hey, red, that sine is opposite over hypotenuse. This is the so in SOHCAHTOA. And cosine is adjacent over hypotenuse. This is where the ka comes from. So definitely remember those things. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Those are the most important things to remember from yesterday and today. Alright. Example 4 says to find the sine and cosine of a 45-degree angle. Well, hey, I know that a 45-degree angle... Oh, no. 45, 45, 90 triangle. There we go. Those legs gotta be the same length. Speaking of legs being the same length, we know that in a 45, 45, 90 triangle, 45, 45, 90 triangle, the legs are the same. We can make this whatever number we want. Doesn't matter. Same thing like what we did with tangent on Friday. All 45, 45, 90 triangles are similar because they all have the same angles. So it does not matter what number we choose for this side length. We can make it anything we want. Let's make it 2. Sure, let's make it 2 just because we can. So if this is 2, what should my hypotenuse be? Remember, in 45, 45, 90 triangles, to get from the leg to the hypotenuse, I'm just multiplying by the square root of 2. So, the length of my hypotenuse should be 2 times square root 2. Beautiful. Okay, next, get a different color in here. We're looking at 45. It does not matter if I look at this 45-degree angle or this 45-degree angle. Does not matter. So I'll just pick this one because I can. Which makes this the opposite. This is the adjacent. And this is the hypotenuse. So, let's do sine first. If I'm looking for sine of 45 degrees, remember sine is so I'm going to take the opposite and the hypotenuse. So sine of 45 degrees is opposite over hypotenuse. And you'll notice, this is why I said it won't matter what number we pick, because look, we get a 2 on the top, and we get a 2 on the bottom, so those just cancel out. And that would happen no matter what number we used. If we had used 4 over here, wouldn't matter, because this would just be 4 times the square root of 2, and it would cancel out. So does not matter what number you use. So this is just 1 over the square root of 2. We could rationalize the denominator if we wanted to, but again, I never used that in math until ring theory, so don't worry about it. Okay, so sine of 45 degrees is 1 over root 2. Now, let's get a different color in here. We're going to look at cosine of 45 degrees, which is, remember the ka, so ka, toa. Cosine is adjacent over hypotenuse. So now we're looking at these two. So adjacent over hypotenuse. Wait a minute. Those two things look exactly the same. Did we make a mistake? Did we do something wrong? No, we didn't. The sine of 45 degrees and the cosine of 45 degrees are one and the same. They are the exact same number. And that is because in this triangle, 2 and 2, the legs of any 45, 45, 90 triangle are the same. And that is why the sine and the cosine are also the same. So again, your 2's cancel out there and you get 1 over the square root of 2. Awesome. Awesome. Cosine of 45 is 1 over the square root of 2. Beautiful. Beautiful. All right. Let's move on to the next example. Yep, look at that. Oh yeah. 1 over root 2 is the same thing as square root of 2 over 2. If you want to know more about that, let me know. I can make a video on it, or we can talk about it on my live stream. Whatever your heart desires, I will help you with. Okay. Our next example is sine and cosine in a 30, 60, 90 triangle. So, let me draw us a... it's not the best, but it'll do. Not totally to scale, but that's okay. 30, 60, 90. Okay, so we want sine and cosine of a 30-degree angle, which means we're going to be looking at this one right here. And if that's the angle we're looking at, that makes our opposite, this side, our adjacent, this side, and of course our hypotenuse is always opposite the right angle. Okay, I need some side lengths on this thing. So, remember the pattern was x, 2x, x root 3? You can pick any number for this, and it's still gonna work out. So we could pick 2, but I think you get it. I think you get how stuff will cancel out from the last example. So let's just use 1. You can use whatever number you want, and I promise you it will still work out just the same as me. So let's use 1. We'll make this x a 1, which makes this 2x 2 times 1. Oh, no. 2 times 1, which is 2. And 1 times the square root of 3 is just the square root of 3. Fantastic. Now, we want the sine of 30 degrees. And remember that sine, so, pause, I'm going to pause so that you can remember what the O and the H stand for. Opposite and hypotenuse. Hopefully you got it. So we're going to do opposite over hypotenuse. And look at that. Sine of 30 degrees is 1/2. Awesome. That's nice. That worked out really nicely. Are there other angles that work out that nicely? Yes. Yes, there are. But you'll learn more about that next year, and in pre-calculus when you get to college. But if you want to talk, oh boy, if you want to talk, we will, for sure we will talk. But sine of 30 degrees is 1/2. That's the main thing that you need to know for now. Okay. Cosine of 30 degrees. Cosine is, remember, so, ka, toa, yes indeed. I'm gonna wait a minute, see if you can remember what the ka stands for. Hopefully you got it. This is cosine equals adjacent over hypotenuse. So now we're using these two. So the adjacent is the square root of 3, and the hypotenuse is 2. So, cosine of 30 degrees equals square root of 3 over 2. You'll notice that these are not the same. Sine of 30 and cosine of 30 are not the same. That's because the legs of my triangle aren't the same. And because, remember from yesterday how we could rewrite sine and cosine in terms of one another? Sine of one angle is equal to cosine of 90 degrees minus that angle. For the 45, that worked, right? 45 plus 45 is 90. 90 minus 45 is 45. So that still follows that rule. This does not. This does not. So these shouldn't be the same, and we did it right. And we can check, make sure that we got it right. Look at that. Look at that. Beautiful. Okay. Our next example, our last example for today, is modeling. Modeling with mathematics. You are skiing on a mountain with an altitude of 1,200 feet. And remember, altitude means how high you are. It's like your elevation. The angle of depression. Does that mean the angle is really, really sad? And that we should make sure to talk to that angle? No, that's not what depression means in this case. What depression means is when we're looking down. The angle of depression, the angle of how far we're looking down. At what angle are we looking down? So the angle of depression of this slope here is 21 degrees. We want to find the distance that we are skiing down the mountain to the nearest foot, because putting tape measures on ski slopes is not safe. And this was the only way we could come up to solve this problem. Yeah. Oh, just need my whole desk. Goodness. Okay. All right. So, we are looking at this angle right here, since that's the only one we have. We are looking at the 21 degrees, which makes this the opposite this the adjacent because the hypotenuse is always opposite the right angle. Beautiful. Okay, so let's see. I'm going to make special note of, I know the 12,000 feet. I know that. So I know my opposite. Beautiful. And I'm looking for my hypotenuse. So I need a trig function that uses the opposite and the hypotenuse. Can you think of what? No, I'm just kidding. We're not going to turn this into Dora the Explorer. But seriously, do you know which trig function uses opposite and hypotenuse? SOHCAHTOA. SOHCA, let me write that down. SOHCAHTOA. Let's see. Opposite and hypotenuse. There it is! Sine. We're going to be using sine. Okay. So sine of 21 degrees is equal to the opposite 1200 feet. You can leave the units in. Or just remember to tack them on later. I don't mind which way you do it. It's whichever way helps you the most. 1200 feet, and the hypotenuse is x feet. Oh, but look, our units cancel out anyway. Okay. Alright, so to solve for this is like what we did with tangent on Thursday or Friday. Gonna multiply by x on both sides to get that out of here. X feet. Same thing. Okay, and now I'm gonna divide. Oh wait, well, let's rewrite this. So now I have x times sine of 21 degrees equals 1200 feet. Now, there we go. Now, see how I want to get the x by itself? I want to get the x by itself here, so I need to divide both sides by sine of 21 degrees. So that those cancel out. Now, rewrite this yet again. So I know that x is equal to 1200 divided by sine of 21 degrees. Beautiful. I don't know what that is in my head, so we pull out the handy dandy calculator. 1200 divided by sine of 21 degrees is approximately, because anytime we're approximating we use the squiggly equal sign, nearest foot. So 3,349 units. Feet. Fantastic. Yes, remember that I like to answer word problems with a full sentence answer, but we are running out of space on this slide, so I'll leave that as an exercise for the viewer. Okay, fantastic. 3,349 feet. That is a long ways to ski down that slope. Goodness gracious. Okay, and let's see where we write. Yes, we were. Beautiful. Okay, that is all I have for you today. Went quicker than I expected, but that's all right. Remember that if you have questions, you should just stop by Mrs. Dodge's live stream on YouTube from 12 to 2 each weekday. We will be happy to see you there and answer any questions you have, or you can just join a Spanish practice party or a singing party, depends on what we want to do today. Alright, your homework for today is 4 problems, but these both also have like 4 parts to them, so it's kind of like 10 questions, but not so bad because they've already set it up for you. So this is your homework for today. And the last thing I have for you is your lunch. So, Here it is. The expert in anything was once a beginner. So my question to you is, what is it that you would like to be an expert in? Is it math? Is it an expert soccer player? An expert in how the brain works? A psychologist? An expert swing dancer? Last example's mostly for me. But whatever it is, you have to start somewhere. So why not start now? Especially when we're all cooped up like this. This is being posted the day after the governor made the 2-week at home, like, mandatory stay home law bill. I don't know the technical word for it. But all that to say, now is a great time to start something new. Do you wanna be an expert in math? Watch a ton of YouTube videos. Watch all the videos. Practice to your heart's content. Do you want to be a psychologist, an expert in how the brain works? Read articles. Watch YouTube videos. There are so many places to find really, really cool videos nowadays. And I can share the links to my favorite YouTube channels to watch that have educational, fun things in them. But I would encourage you to use this time to start something new. If you want to be an expert, you gotta start as a beginner. So that is my launch to you. Take it for the rest of your day, and hopefully I'll see you on the live stream later. But if not, have a good rest of your day. Bye.